everything you know will vanish. Not just you, or Earth, or even our galaxy, but every single atom in existence will face the same ultimate fate. And the universe has already chosen how it ends. The countdown started 13 billion years ago, and we've only recently discovered what's coming. Back in the late 90s, two separate teams of astronomers were measuring exploding stars called supernovae across distant galaxies, and what they found made absolutely no sense. These stellar explosions were dimmer than they should be, which meant they were farther away than physics predicted. Something invisible was pushing the universe apart from the inside, and that force was getting stronger. They called it dark energy, and it makes up 69% of everything that exists. The remaining 31% is split between dark matter and all the normal stuff like stars and planets and you. We're basically a rounding error in cosmic accounting, and that tiny fraction is about to matter a whole lot less. Right now, galaxies beyond about 13 billion light-years are already lost forever. They're racing away faster than light can travel, which means no matter what technology we invent, we can never reach them. Their light is stretching into longer wavelengths, redshifting into darkness until they blink out of our observable universe completely. But here's what keeps cosmologists awake at night. Dark energy isn't slowing down. Every measurement we take, every telescope we point at the distant universe, confirms the same terrifying truth. The acceleration is relentless, and it's rewriting the rules of cosmic survival.
Value beat 3. The trillion-year timeline begins. In about 2 trillion years, the night sky will go dark. Every galaxy outside our local neighborhood will have accelerated beyond our cosmic horizon. Future astronomers, if any exist, will look up and see only the merged remnants of the Milky Way, Andromeda, and a handful of dwarf galaxies. They'll have no way to know that billions of other galaxies ever existed. The universe will have erased its own history. By 100 trillion years from now, every star that can possibly form will have already burned out. No more nebulae glowing with newborn suns. No more planets warming in stellar light. The era of stars, the only era we've ever known, will be over. The cosmos enters what scientists call the degenerate era, where galaxies are nothing but scattered corpses, white dwarfs, neutron stars, and black holes drifting through the expanding void. Value beat 4. The reign of black holes. For an almost incomprehensible stretch of time, black holes become the last bastions of organized matter in the universe. These gravitational monsters will outlive everything else, consuming whatever stray matter drifts too close, while slowly evaporating through a quantum process Stephen Hawking predicted. Smaller black holes with masses like our Sun will disappear first through Hawking radiation, releasing their particles back into the void over trillions upon trillions of years. But the supermassive giants lurking at the centers of dead galaxies will persist far longer. We're talking timescales that make the current age of the universe look like a single frame in an infinite movie. A Google years, that's a 1 followed by 100 zeros, will pass before even the largest black holes finally surrender to quantum decay. And then comes the final act, the dark era. No stars, no planets, no black holes, just an ever-expanding bath of subatomic particles spreading across incomprehensible distances, slowly cooling toward absolute zero. This is heat death, but the name is misleading because it's really the death of heat itself.
Temperature differences are what make things happen. Hot flows to cold. Energy moves. Life emerges. But when everything reaches the same temperature, when every particle is separated by light years of empty space, hovering just above the coldest temperature physics allows, then thermodynamics shuts down completely. There's no energy left to do work, no potential for chemistry, no possibility of life, even the simplest imaginable kind. The universe will have achieved maximum entropy, and in that state, nothing can ever happen again. Just particles drifting through infinite darkness for eternity. The terrifying alternatives. But here's where it gets worse. Heat death assumes dark energy stays constant. Recent measurements hint that it might be strengthening. And if that's true, we face something far more violent called the Big Rip. In this scenario, dark energy doesn't just separate galaxies, it tears apart everything. First, galaxy clusters dissolve, then galaxies themselves, then solar systems, then planets, then you, then your atoms, and even the quarks inside those atoms. Space itself becomes infinitely fragmented in a cosmic unraveling, where every point becomes infinitely distant from every other point. The universe doesn't fade, it detonates from within, destroying even the fabric of space-time. And there's another possibility that makes the Big Rip look merciful. The quantum vacuum might not be stable. Right now, the fundamental forces in particles exist in what could just be a temporary configuration. A random quantum fluctuation anywhere in the universe could trigger a phase transition, a bubble of new physics expanding at light speed, rewriting the laws of nature itself. Everything inside atoms, bonded by forces we understand, gets replaced by particles and forces incompatible with our existence. You wouldn't see it coming. One instant, you're here. The next instant, the bubble arrives and the universe you knew simply ceases to exist, replaced by something utterly alien. Closing. The comfort in cosmic time. If this sounds bleak, remember that even the nearest of these endings is so far in the future that the entire history of life on Earth represents less than a blink. Humans have existed for a fraction of a cosmic second. The sun will consume the Earth in 5 billion years, which sounds catastrophic until you realize that's still 4,999,990,000 years before the last stars even begin to fade. The universe may be doomed, but on the timescales that matter to anything remotely resembling life, the end is so far it might as well be infinite. We live in the brief golden age when stars shine, galaxies glow, and complex structures can emerge from chaos. The universe won't end with a bang or a whimper. It'll end with the slowest, longest silence ever conceived, and we won't be around to hear it.